Day 435 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1900, the earliest and latest rounds where players compete. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a tournament where N players are participating. The players are standing in a single row and are numbered from 1 to N based on their initial standing position. Player 1 is the first player in the row, player 2 is the second player in the row, etc. The tournament consists of multiple rounds starting from round number 1. In each round, the ith player from the front of the row competes against the ith player from the end of the row, and the winner advances to the next round. When the number of players is odd for the current round, the player in the middle automatically advances to the next round. For example, if the row consists of players 1, 2, 4, 6, and 7, player 1 competes against player 7, player 2 competes against player 6, and player 4 automatically advances to the next round. After each round is over, the winners are lined back up in the row based on the original ordering assigned to them initially, which is ascending order. The players numbered first player and second player are the best in the tournament. They can win against any other player. Before they compete against each other, if any two other players compete against each other, either of them might win, and thus you may choose the outcome of this round. Given the integers n, first player and second player, return an integer array containing two values, the earliest possible round number and the latest possible round number in which these two players will compete against each other. All right, y'all, so I understand that's a lot to take in right there. That was a long question, but don't worry about it. Let's get into these examples just to make sure that we're doing this problem correctly. So in example 1, we have our input n equals 11, our first player equals 2, second player equals 4, our output is 3 and 4. So before we look at the explanation, let's just go through what this input means. So this means we have 11 players. That's this right here. Boom. I'm going to copy and paste this over here for y'all. Boom. So those are our 11 players. Player 2 and player 4 are the best players. This player and this player are the best players. We want to see how many rounds it'll take, or excuse me, we want to see what's the earliest round it'll take for them to play each other and what's the latest round it'll take for them to play each other. So let's go through these examples to just so we can make it make sense a little bit more. So in example 1, one possible scenario which leads to the earliest round number. The first round we have all the players, which is over here 1 through 11. Second round we have players 2, 3, 4, 5, 6, and 11. So let's see how they got this for the second round. 2, 3, 4, 5, 6, and 11, right? So it says right here, if any two players compete against each other, either of them might win, and thus you may choose the outcome of this round. So we can choose who wins in the initial rounds, right? So it's not set in stone who's going to win, but let's see how they got. These are the winners. Let's see how they got these winners. So first thing they did, remember, so the ith player played at the front of the row, plays the ith player at the end of the row. So first one plays 11, right? Boom. So as we can see, 11 won that one. So we could get rid of of 1, right? Boom. And we could move this 11 down here. We could move 11. Let's just call this second row right here. This could be, call this the winning bracket. Boom. So 11's in the running bracket. Then 2 will play 10 once again. So 2 won that one, right? So now we get rid of the 10, 2 1. So remember, we have to keep it in the original order, right? Keep the original order. So 2 beat 10, boom. So we get rid of the 2 as well, move 2 to the winners bracket. Then this 3 will play this 9, right? And what they say, so 3 wins. So we could get rid of this 9. We can move 3 down to the winners bracket. Boom. Then 4 plays against 8, right? 4 wins. So we could get rid of 8 and we could move 4 down to the winners bracket. Boom. Then 5 plays against 7. 5 wins. So once again, boom, we can move 5 down to the winners bracket. And since 6 was in the middle, it says the people in the middle automatically win, right? So player 4 automatically advances to the here it is. The player in the middle automatically advances to the next round. So in this case, that would be 6. So 6 is going to automatically advance to the winners bracket. Boom, because it was in the middle. Boom. So now this is our winners bracket for after this first round. And that's this. Now we have our second round. So in our second round, we do the same thing. 2 competes against 11. Boom. 2 wins. So we get rid of this 11. We can move 2 down to the winners bracket. Boom. Then we do 3 against 6. 3 is going to win. So we get rid of 6. We can move 3 down to the winners bracket. Boom. Then we do 4 against 5. 4 is going to win. It's the best in the game. It was second player, second best in the game. So, excuse me, this should be a 4. Sorry, y'all. 4 wins when it plays against 5. So we can move forward to the winners bracket and we can get rid of the 5. And finally, once again, 2 plays against 4. So that's the earliest round that we can create where the first player and the second player, 2 and 4, go against each other. We got here in 3 rounds. Now 2 plays against 4. Boom. And you already know 3 would automatically go. Boom. So that's how that works. It's similar. This is the same thing. We're not going to go through it, but it's the same principles. Only difference is this is the possible scenario which will lead to the latest round. And in this case, it will take 4 rounds. We're returning how many rounds for the early rounds and how earliest round and how many rounds for the latest round. So in this case, it'll take 3 rounds for the earliest round. It'll take 4 rounds for the latest round. And this is how they got to the latest round. Same principles apply. We're not going to go through it, but you can go through it on your own if you want to. So now let's take a look at example 2. In example 2, we have the input n equals 5, first player equals 1, second player equals 5. The output is 1 and 1. Explanation says the players numbered 1 through 5 compete in the first round. There's no way to make them compete in any other round. So just so y'all can see what that would look like, we have 1, 2, 2, 3, 4, 5. And as you can see, first round 1 is competing against 5. 1 is the first player, 5 is the second player. That's the competition that we're looking for. Happens in the first round, so we don't need to go any further. So now that we understand the question, y'all, let's get into the fun part, the actual solution, the part that all brought us here in the first place. Now, first thing we're going to do is we're going to normalize the player positions to mirror symmetrically or symmetry, from front and back. So we're going to, first thing we're going to do, we're going to open up the square brackets. We're just going to say first player. Then we're going to come, still inside the square brackets, comma, second player, just like this. Boom. Then we could come underneath this. We could do it in one line, but I'm separate it in multiple lines just so it's easier to read. So the second line, we're going to say dot map. We're going to open up the brackets, and we're going to say min, parentheses, $0, comma, n plus 1 minus $0. Boom. So what this is going to do is this is going to map both players to their equivalent position from the start of the list. Then we're going to come underneath this and we're going to get the minimum and the maximum positions after normalization. So to do that, all we have to do is come underneath this and we can say dot min and max, just like that, and put the parentheses. Then we're going to come underneath that and we're going to say dot flat map, and we're going to open up the brackets. Then we're going to open up the square brackets. We're going to say half equals, open up the parentheses, n plus 1. Come outside of those parentheses. We're going to divide that by 2. Come outside of that square bracket. We're going to open up some more parentheses, and we're going to say R1 colon, that's going to be an integer. Then we're going to say comma R2 colon, that's going to be an integer as well. We're going to come outside of those parentheses. We're going to return, we're going to return an array of integers, put a question mark after the square bracket, and we're going to say n. Boom. Then we're going to we're going to say product, product, open up the parentheses 0, dot dot less than R1, comma 0, dot dot less than R1, or R2 minus R1. Just, that should be a R, sorry y'all, R1, just like that. Then we're going to come underneath these parentheses and we are going to say dot map. We're going to open up the brackets. We're going to say open up some more square brackets, and we are going to say if, we're going to say is same side. Then we're going to say equals, and we're going to open up some more parentheses. We're going to say first player is less than half. Come outside of those parentheses. We're going to say equals. Open up parentheses. We're going to say second player is less than half. Then we're going to come outside of those parentheses and the square bracket, and we are going to say, or we're going to open up some more parentheses, and we're going to say C1 colon, that's going to be an integer. Then we're going to say comma C2 colon, that's going to be an integer as well. And this is going to come outside of those parentheses, and this is going to return a tuple of integers. So open up the parentheses, int, comma, int, just like that. Come outside of those parentheses and we say n again. Boom. Then we come underneath that and we're going to calculate the new position in the next round depending on pairing and the bracket size. So we're going to come underneath this, we're going to come right here, and we're going to say C1 plus 1, or sorry, this should be in parentheses, so open up the parentheses, boom, C1 plus 1, come outside, or after the 1, we're going to say comma, then we're going to say C1 plus C2 plus 2 plus, open up some more parentheses, is same side, question mark 0, then we're going to say colon half minus R2, just like that. And that's going to offset the adjusted base, that's going to adjust the offset based on the relative side. Then we're going to come underneath this bracket right here and we're going to say dot flat map, open up some more brackets and open up some more parentheses, and we're going to say P1 colon, that's going to be an integer. Then we're going to say P2 colon, that's going to be an integer as well. Come outside the parentheses, that's going to return an array of integers. Come outside of that array, that square bracket right here, and we're going to say n. Boom, again. Then after that, we're going to come underneath that, we're going to say earliest. We're going to use some recursion here by saying earliest and latest. Boom. Open up the parentheses, and we're going to pass in half, half, comma, P1, comma, P2. Boom. Come underneath this bracket right here. We're going to say dot min and max. Put the parentheses. Come underneath that, and we are going to say dot map. Open up the brackets. We're going to say $, or open up the square brackets as well. Then we're going to say $0 dot min, and we're going to say +1, then comma, $0 dot max, plus 1. And that's going to add to the account for the current round. Then we're going to come right here after this bracket, and we're going to say question mark, open up the square brackets. We're going to say 1, 1, and that's going to be a base case that they meet in the first round. Now, that should be all she wrote, y'all. I know that code was a little bit confusing, but let's run it, make sure it runs properly before we submit it. Let's see, it's taking a little while. So I can only imagine there's an error somewhere. Hopefully it tells us. Or is my computer just slow? I don't know. Okay, we got an error. We got an error. It says separator, expected separator. So let's see if we could find where go. Line 9. Cannot find R in scope. Okay. Dang. Sorry, y'all. It's right here. That's what we was looking for. Now let's run it again, see what happens. Dang. Sorry about that, y'all. So let's go ahead and submit this. Make sure it's still accepted after we submit this. And it's accepted, y'all. Look at that. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see, y'all. So with that being said, make sure you get one more look at the code. It's not that much code. And yeah, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.